Welcome to my video lecture. I am Dr. A.VELMURUGAN, Associate Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmaburi. In this video lecture from upcoming semester, Automobile Engineering, Unit 5, Alternative Energy Sources. From Module 5, we can discuss about the electric vehicles, hybrid vehicles, and also we can discuss about the turbocharger. Finally, we can discuss about the three-way catalytic converters. So from this slide, we can discuss about the electrical car and hybrid vehicles introduction. From that, electrical cars are automobiles which are powered by the electric engine and the electric energy. The development of the electrical vehicles is a very perspective and important process. So from the electrical vehicles are vehicles that are powered by an electric motor instead of an internal combustion engines. From this slide, we can discuss about the history of the electric vehicles. The history of the electrical vehicles began in the mid of the 19th century. From the year of 1832, Robert Anderson invents a non-rechargeable electric carriage. From the year of 1835, Thomas Davenport built the first practical electrical vehicles. From the year of 1976, General Electric was chosen to construct a parallel hybrid sedan model car, and Toyota built its first hybrid cars. So from that electrical vehicles, we can using these are all the important components used for the electrical vehicles. That is a motor, controller, charger, and DC converters, contractors, and batteries. So next slide, we can discuss about the what is mean by hybrid car. So generally, the hybrid car is a vehicle that runs on not only gasoline but a rechargeable battery. From here, the hybrid car is not only run for the gasoline engine, but also we can run this vehicle with the help of this rechargeable battery. And the next point with from the petrol and electrical hybrid cars are both on electrical motor, and also we can using the gasoline motors. It also consists a rechargeable battery for the electric engines. From this hybrid car, the fuel in the car is powered to power the petrol engine, and the electric batteries supply the power to this car for the electric motors. Some of these new hybrid cars are now converting the kinetic energy into the electric energy to power than batteries. Means from here we can using this type of hybrid cars with we can applying the brake, we can get the energies, that is a regenerative braking system. For that energy, we can store the energy will be stored on the battery. From the process of that, if the wheel will be applying the brake, the wheel will be make the jerking. Means for that time we get the kinetic energy. That kinetic energy is converted into electric energy. That energy will be stored on the batteries. So next slide, we can discuss about the various types of hybrid cars are present. The first one is series hybrid car. How to the series hybrid car is working means with the help of that internal combustion engine, with the help of the petrol to operate the internal combustion engine. From the internal combustion engine is coupled with the generator. That the generator is produce the electricity with the help of the inverter. Inverter, the energy will be stored on the battery. So we can operating this series hybrid car means we can get the power from the electric motor to drive this wheel. So next one is a parallel hybrid vehicles. From here we can using the internal combustion engine. From that, with the help of the petrol, we can run the internal combustion engine. So after that, with the help of the battery also we can get the energy from that inverter and the battery with the help of that generator to drive the vehicles. So generally from the parallel hybrid vehicles are operating from the three mode. If you operating this vehicle from the lower speed means the power will be get from the electric motor to drive the wheel. If you are operate the vehicle from the medium speed means from the power will be get in the IC engines to drive these vehicles. For example, if you rotate, if the vehicle will be operating on the high speed means that IC engine is operating on 1 rpm and the electrical motor is operating on the 1 rpm. So with the help of that power transmission, that is a power split transmission device or power split device to control the speed, it will be rotating on the 1 rpm to drive these vehicles. Next one is that is a series parallel hybrid. So for this system we can rotate the vehicles with the help of that internal combustion engine and also with the help of the battery power to drive these vehicles. So next one is a complex hybrid. From here we can operate this vehicle with the help of the internal combustion engine to drive this vehicle, and also we get the energy from the internal combustion engine from that generator, that with the help of that generator, that electricity energies goes to the battery with the help of the inverter. So we can drive this vehicle with the help of this complex hybrid cars. So next slide, we can discuss about the the parallel hybrid. Here we can see about the schematic view of the parallel hybrid system. So how to we can run the parallel hybrid system means here these are all the important components are present. That is a internal combustion engine, generator, power electronic drive, power another power electronic drive, and a propulsion motor, and a battery and a charger. So generally we can operate these parallel hybrid vehicles means we can operating from the three mode. The first mode is we can operating the low speed mode means so only the motor gives the power to drive this vehicle. After that we can operating the medium speed means from the internal combustion give the power to drive this vehicle. For if that the vehicle is operating on high speed mode means so with the internal combustion is operating on 1 rpm and the electric motor is operating on the another rpm. So with the help of that power split transmission system, from the power split transmission system there will be one more device is that power split device. That device is control the speed that vehicle is running on another rpm. This is the process is going on the parallel hybrid system. And also from here we can using this drive this vehicle from this parallel hybrid system. So if you are applying the brake from that brake means applying from the brake of the vehicles means from that time the wheel will be making for the skirting. So for that time that the vehicle will be stopped. For the time we get the kinetic energy. That kinetic energy is converted into electric energy. That energy is stored on the battery. That process is known as the regenerative braking system. So next we can discuss about the series hybrid process. From the series hybrid process, we can drive the vehicle only for the motor. So from here we can using the internal combustion engine. That internal combustion engine is coupled with the generator. We can from the generator that is we get the electricity with the help of the energies stored on the battery with the help of the inverter. But this series hybrid vehicles only with the help of the motor to drive this vehicle. So this is the process going on the series hybrid vehicles. So next slide we can see about the parallel hybrid vehicles and the series hybrid vehicles. From the as I told about earlier, from the parallel hybrid vehicles, we can operate this vehicle in the internal combustion engine and also in the motor from the battery charge. But in the series hybrid vehicles, only we can operating this vehicle with the help of motor. But the internal combustion engine is coupled with a generator. That generator is that energy stored on the with the help of the inverter and the battery. So next slide, we can discuss about the various types of parallel hybrids are available from the manufacturing side. So generally, the first one is the parallel hybrid that parallel hybrid is manufactured by the Toyota Prius. From the motor is used for the expensive engine plus that a cheap electric motor. From here, the transmission system is expensive 10-speed or CVT. From here, we can using the gas tank. From the battery capacity is very cheap, less than 1 kilowatt. The overall cost is moderate price. So next one is series hybrid. That series hybrid is manufactured by Nissan e-Power. From that the motor of the engine is cheap engine, runs at constant velocity plus a cheap electric motor. And also from the transmission system is cheap single speed. From here we can using the gas tank. From the battery capacity is cheap 2 kilowatt, and the overall cost of this vehicle is moderate plus Nissan sells about 60% of the price of this Leaf in the Japan. So next one is a plug-in hybrid. This type of car is manufactured by the Chevrolet Volt. That engine is the cheap engine, runs at a constant velocity, or expensive engine plus at a cheap electric motor. The transmission system is cheap single speed or CVT. From here we can using the gas tank and the charger. The battery is moderate cost around 15 kilowatt. The overall cost of this vehicle is high, but buying two complete powertrains get expensive. The tax credit also available. So next one is we can see about the fully battery electric vehicles. This vehicle is invented by the Tesla. So from nowadays worldwide we can that people are purchasing the battery electric vehicles, that is manufacture of Tesla vehicles. From here we can using this motor is cheap electric motor, and the transmission system is cheap single speed. From here we can using the charger. From the battery capacity that is expensive of 40 to 100 kilowatt, but overall cost is high but dropping quickly. Tax credit is available. So next slide, we can discuss about the turbocharger. So generally the turbocharger is used for the internal combustion engine. So how the turbocharger is come to the worldwide means because of the turbocharger is invented in the from the application of aeroplane and ships. So why we have to using this from the aeroplane means because of the aeroplanes operating on the cold conditions. For that conditions we need record of the air, but that hot air is not record. So for that condition we can using the turbocharger. From the turbocharger, that is a blow air, compressor and a turbines are important components mounted on the same shaft. The compressor is run by the turbine and the turbine is turned in the run by the exhaust gas. From the turbocharger we can these are all the important components, that is internal combustion engine, heat exchanger, turbine, blow air. After that the compressor is mounted in the same shaft. So from that we can operating the internal combustion engine. From that exhaust manifold, the exhaust gases goes to the turbine. So we can rotate the turbine to impinges to rotate the turbine blade. So from the turbine blade is coupled with the same shaft of the centrifugal compressor. That the compressor work is that ambient air is suck the ambient air, that low pressure air is delivered for the high pressure air from the centrifugal compressor. That high pressure air is directly goes to the internal combustion engine means it will be very difficult. So for that condition what we have to do, it means in between this hot air we can using the heat exchanger, that is heat exchanger name as intercooler. From the application of this intercooler is we can hot air is converted into cold air, that cold air is entered to the turbocharger. So next slide we can see about the photographic view of the turbocharger. First we can see the design of the turbine and the compressor. From here the design of the compression design of the turbine is one shape and the compressor is another shape. So generally that the hot exhaust gases goes to the turbine. We can rotate the impinges to rotate the turbine. That the turbine is coupled with the compressor shaft. So the compressor work is to suck the air, to that suck the ambient air, that centrifugal compressor to the low pressure air is compressed and deliver the high pressure air. That high pressure air is goes to the intercooler. That intercooler is to changing the heat exchanger. After that the cold air is goes to the from the inlet manifold. So next slide we can discuss about the three-way catalytic converters. So nowadays we can using to control the dilute the emission. That is a major emission in that internal combustion engine means first one is hydrocarbon emission, second one is carbon monoxide, third one is oxides of nitrogen. So we can control these three emissions with the help of this catalytic converter, that is a three-way catalytic converter. So generally the catalytic converter is made up of honeycomb structure. It is fitted on the exhaust manifold. So we can provide this high quality technology and also including but not limited. So if using the three-way catalytic converter means we get the lean NOx technologies, oxidizing the soluble organic fraction, that is a we can control the particulate matter reduction, and also we can oxidizing the carbon monoxide and hydrocarbon and oxidizing the other emission to reduce the diesel odor. And also if using this catalytic converter means we get the other advantages, we get the passive operation and regeneration is not required. Highly efficient platinum and palladium catalysts are used and it is a proven fuel durability. So generally from the exhaust gas we get the harmful emission. The first one is hydrocarbon emission, second one is a carbon monoxide, third one is oxides of nitrogen. So this gas is entered to the catalytic converter. So from the catalytic converter is from the shape is that is honeycomb structure. From here there are different types of catalysts are used. From here the palladium and the rhodium is that is a phase changing reaction. If that exhaust gas is entered to the catalytic converter means we can change the reactions. From the inlet of the exhaust gas is entered to the catalytic converter, that is unburned hydrocarbon, carbon monoxide, particulate matter and oxides of nitrogen. From here we can using the catalyst is that is a substrate and a technology and a precious metals, that is a palladium and rhodium. From in between this catalyst we can using the interments mat, that is insulation and packaging surfaces. From here we can using different types of catalysts are used. The first stage is diesel oxidation catalyst, the second one is a catalyst or diesel particle filter. So why we have to using means the first stage of diesel oxidation catalyst is to dilute the hydrocarbon, carbon monoxide and oxides of nitrogen, and another stage of catalyst diesel is to control the particulate matter. So generally from the catalytic converter it is made up of honeycomb structure. For example, if the hot gas is entered to the catalytic converter means we can change the phase reaction. Finally from we get the from the tailpipe of the exhaust that the gases goes to the atmosphere, we get the tailpipe emission, we get the H2O, that is a water, carbon dioxide, nitrogen and oxides of nitrogens. So next slide, we can discuss about the diesel particulate filters. So what is the purpose of using the diesel particulate filter? Means from here we can see this structure is ceramic honeycomb wall, and also from here we hear that carbon monoxide, hydrocarbon, and particulate matters are entered to the diesel particle filter. If that gas is goes to the this honeycomb structure, means from the outlet of we get the exhaust is carbon dioxide H2O and out. So if using this diesel particulate filter, means we can reduce the 80 to 95% of particulate matter, and also 80 to 100% of hydrocarbon, carbon monoxide, and 80% toxin emissions also used. So if using this particulate filter, means that is issues of balance and surface formation and regeneration, the back pressure, and we get the fuel economy. So if using this three-way catalytic converter from the internal combustion engine, means particularly from the diesel engine or petrol engine, we can dilute the carbon monoxide, hydrocarbon, and particulate matter and oxides of nitrogen, so that gas is entered to the catalytic converter with the help of the honeycomb structure, and to dilute the emission. Final output is we get the carbon dioxide, water, and outlet. Thank you.